Hi, everyone, and welcome to AI Simplified. I'm Phil.
I'm Najim.
And I am Amjad.
And we're your podcast hosts today. Amjad, how are you?
Phil, I'm doing splendid this morning. And how about you?
Doing well, doing well. Tell me, what are we going to talk about today in our podcast?
Yeah, so today, Najim and I, we are going to talk about language models and generative models, and we'll use GPT-3 sort of, as the context of our conversation, and talk about how these models they play a role in the overall AI architecture and how businesses can benefit. From that. So Najam, we have some wonderful content prepared, which is meaningful. Hopefully, everybody will like it. But just to maybe frame the conversation about natural language, maybe Phil, you want to bring up some of our pointers or slides on that topic. And yeah, so this is a good one. So as you can see, I'm enjoying my tea as well. So look, if we look at any AI architecture, we have said that you use all different methods to sense the environment, process all the data that is coming in, and we usually call it perception. And it's all computation. And then whatever reporting out, communication that has to happen, we use the faculty of language, so that's natural language, and faculty of vision, so that's data visualization, as means to interact and communicate with people, right? Now, we all know meaning is very human-centered, human-focused in terms of how we talk about meaning. So then language is a unique human trait. Vision is a unique human trait. And we combine these two. So today we are going to, in the time that we have, we are going to really focus on these generative language models. So I'll say a few things and I'm going to give it to Najam for Najam to jump in. But if you think about one common natural language use case is you have a lot of data, some structured, some unstructured. You want to be able to do an effective Q&A with you and your software, you and your computer. I'm going to stop using the term AI more and more because as time goes by, it is going to be in everything. It already is in us, and we are putting it into computers and devices. So it's not going to be any different. So that distinction is going to become also less important. So teaching Q&A and those types of capabilities to computers is a very useful skill. This is where these generative models come, like GPT-3, come very handy. Najam will talk about that if it is GPT-3, what was GPT-2, and what does GPT-4 and GPT-N trajectory look like. But I'll make just one last point, and I'm going to give it to Najam. And that point is, since AI is architecture, there are components of architecture, right? And one way to look at the components are horizontal components, vertical components. So horizontal components are industry generic components, a component or a Lego block to just have fundamental natural language skills or fundamental ability to see stuff in the universe, right? There is no need for everybody to reinvent the wheel, right? So the same way that today, we don't try to build our own AWS or Azure or going back in time, our own electricity or our own internet, unless we have some ulterior motives. So topic for some other people, some other day. There is this need for generic horizontal models that some companies train and others use them, whether others are companies or for-profit, non-profit, universities, people, whatever, right? So that I think is what GPT-3 is an example of. We will dedicate a future episode on all kind of vertical models and horizontal models. So GPT-3 is an example of a horizontal model. A vertical example would be somebody is in an industry, some very specific, scientific manufacturing. And they want to teach their AI some very specific vertical skills. Well, generally then for vertical skills, you got to do it yourself. You don't have so many options out there in the market to buy vertical skills. But horizontal skills, the same way that you are using AWS or Azure and you are using databases and programming languages and a bunch of other things, you are building upon it in your architecture. Your architecture should be able to use these horizontal models. I mean, think about GPT-3. It is a model trained with, or it has, a little shy of 200 billion parameters. Well, these are quite a bit of parameters. But just a few weeks ago, Google came up with something with 1 billion plus or whatnot. So competition, in efficient capital markets is a good thing. So it's a good thing for different companies to come up with these competing horizontal models, and consumers, both as business consumers and individual consumers, to have those choices. But then what it is that I do as a business, Phil, that a point that we always make is, do we have as a business architectural sophistication to embed these types of horizontal models effectively and efficiently? So that, I think, is the broader point of horizontal models, how they can serve as catalysts. You can make a lot of progress very quickly. So with that, Najam sir, I am going to give it to you and go back to enjoying my cup of tea.
All right, awesome. Thanks, Amjad. So I think I should start by reaching out to Phil and saying, well, for one, are you excited about learning more about GPT-3?
Oh, absolutely. I've been looking forward to it all week.
Awesome. And another question that I had was, do you have some sense of the sort of thing that GPT-3 is? Have you heard about it? I know that it's been in the news quite a bit in the last several months. Yep. So maybe you may have come across it.
Mm-hmm. Yeah, I've read some articles about it, and I've seen conflicting views that it's being used for good, it's being used for bad. So would love to, in this podcast, to hear both your take, Najam, and also Amjad.
Yeah, absolutely. Okay, well, by no means am I trying to structure this as a lecture or anything like that, but I think it would be good for me to just bring up an outline of what we may talk about.
Najam, lecture, our podcast? What are we talking about now? So it's so refreshing to have you with us.
Yep, I'm really glad to be here. Really excited. So when it comes to GPT-3, it is a technology. It's a deep learning model that was created by OpenAI, which was co-founded by Elon Musk. And its goal is to sort of democratize the progress that we're making in AI and not have it concentrated in just a few organizations. So the idea is that we have a generic model, right? And we feed it a bunch of information, probably from the internet at this point. And then once it's trained on that information, instead of just spitting out answers or parroting back very fixed phrases that it has learned or stored in a hard drive somewhere, it sort of absorbs that information, right? and it detects patterns in that information. And so this could be text, and in this case, it is text, but there's no stopping anyone from feeding in, let's say, images or feeding in sounds, and then the model, the software, identifying patterns that you or I wouldn't be able to articulate, right? And then building more sophisticated, higher level patterns from those patterns and from those patterns until there are several layers of these patterns, and it can, in a sense, understand without actually understanding what is being presented to it, and it can creatively generate some output. Right, for text, that would mean that if you provided some sentence or a paragraph or even an entire book, and you say, okay, now that I've showed you this thing, give me, the next 20% or the next 50% or, however much more you would like of the same thing, right? So if I give it a sentence and say, write another sentence like this, it'll try to, let's say, complete the paragraph, right? If you give it half a sentence, just a few words, then it'll try to complete that sentence. If you give it a chapter, it'll try to create an entire book out of it, right? Depending on how much you ask it to produce. So that's the general idea of what GPT overall does. Now, the second version of it wasn't as sophisticated as this third version, which we'll get to in a moment. But even at that point, and this was, I believe, about a year and a half ago when GPT-2 was the latest thing, OpenAI decided not to release the most sophisticated and most highly trained version of GPT-2. They said that may be dangerous. And once again, we'll get into why that could potentially be a danger. But it's very interesting that now we've moved on to GPT-3, which blows GPT-2 out of the water. As Amjad said, we're really scaling up the size of these models, the amount of information that we're providing to train this stuff. And the results are simply astounding. Nothing like it has ever been made public before.
One thing, Najal, that I'll jump in here and say is that we have said previously that one good thing about deep learning is it continues to linearly scale with the data. So as you have more data and bigger networks, they are able to make use of it. That is what really excites me about this current sort of phase of narrow AI that we are in, with deep learning sort of as the main method. Few of the points that I'll make, while we don't really understand the theoretical foundation or physics of why and how deep learning models are so effective. Sometimes people describe it as unreasonable effectiveness of these methods. They are unreasonably effective, really, really effective. But hey, while that theory will catch up, I'm glad that the people who are the hustlers, the hackers of this innovation, and the theorists would say, you guys are tinkering, with these models and whatnot. Totally cool. But all empirical evidence suggests that so far, deep learning continues to scale with data, which gives me hope that as, the GPT-4 or 5 or other companies' models like, Google or others who are coming up with new models, as it goes into, as opposed to 200 billion parameters, 1 trillion parameters, and it gets to see more data, meaning it is not just, batch mode, meaning GPT-3, if memory serves me correctly, was trained on all data available on public internet all the way through some date in October of 2019 is kind of what my understanding is. But future architectures that keep using more recent data as well. I am really hopeful and excited about that. That is why I also think this time around, we are not going to run into an AI winter because previously, pre-deep learning, all prior methods, they plateaued off. No matter how big you made those models and how more data you threw at them, after a while they said, I am not going to learn anything new. I am done, you know. But so this now, it looks like, you know, as these models can scale with us as the universe in its sort of, you know, broader sense, the universe that we all consciously experience gets bigger and bigger in terms of our inner universes of discourse, and more data is available. It looks like these models can benefit from that. And that is, I'm hugely excited, Najam, about it, sir. Back to you, sir.
Yeah, absolutely. Now, building on that point, one of the very interesting questions in philosophy of mind and related topics in cognitive science is the emergence of consciousness, right? How is it possible that these neurons that are by no means conscious individually can produce something that is conscious, right? And while I'm not saying that GPT-3 is conscious or anything like that, there is an analogy here where initially when we were talking about GPT-1 or GPT-2, it was that technology was behaving as a text completion tool, right? So you have a few words and it just churns out more words to complete what you had beforehand, right? Now, this is something else. At this point, we are seeing patterns emerge that are more than just that, right? So instead of just being able to complete sentences, now it can understand that it isn't just looking for characters or letters that should appear after the letters that were provided, or words that should appear after the words that are provided. Now it can even pick up on tone or style. It can pick up on sentiment, right? So those are sorts of things that no one programmed GPT-3 to understand, but just by seeing many orders of magnitude more information, real world examples, being able to observe the world that much more and build a model or train its brain on all of that stuff was enough to bring about these emergent things. And that's sort of like empirical proof of a hypothesis in philosophy, which is fantastic.
Yeah, and Najam, to build upon it, what I would say also is that today GPT-3 is since it's generic and it is horizontal, it is an attempt, you know, it is just bringing all data in. So it is a generalist model. It doesn't specialize with one thing. But I have seen, you know, working with you, you know, we can generate some reasonable SQL and whatnot. Mm-hmm. But my excitement is that when, you know, in future, you just train GPT-3 on SQL or Python or something like that, right? With all the code written up till now. And then you just, in the prompting, in the prompt engineering, you just set up and say, okay, here is my database schema. And, mm-hmm. and now, you know, here are some sample, you know, Q&A, you know, written in natural language style where, you know, it figures out how to write the SQL, bring the answers back and all that good stuff. All kind of applications. And I know I'm stealing your thunder, so giving
not at all.
Giving it back to you.
Yeah, no. It's great that you pointed that out because, like I said, it's not just completing text, it's doing far more than that, right? Now you can actually set it up so that the text that it's completing is in the form of a conversation where, you know, you just give it a few examples. You give it an example of, if I type this, then one of the potential expected responses from a chatbot-like entity could be such and such, right? And then after that, you start asking it questions in earnest, and it uses that example and its previous training to generate reasonable responses. You can specify the sort of style of response that you want. So that, you know, if you want something that's chirpy and bubbly, it could do that. Or if you want something that's completely factual, you can accomplish that. If you want something that is psychotic, you can also accomplish that. So it does provide that, which is not something you think of when you think of text completion, right? You can do translation by giving it examples of translation from, you know, I don't know, French to Swahili or whatever languages you want to. You can, as you mentioned, generate working code from simple descriptions of what you want the engine to generate, right? You say, okay, I want a square window with an icon in the top left and a button, and if I click the button, I want this text to appear. And it generates the code, and you can run that code just because it's seen examples of that programming language in the wild. So it's astounding that it's able to do that. It can summarize, it can answer questions from a passage of text. And yes, it's being used as we speak by writers, journalists, ideators, innovators to just come up with ideas. I know that there's even a few Twitter accounts that post business ideas just based on keywords, right? You enter a few keywords and it actually produces a bunch of cool ideas for school projects or for business ventures or whatever you want.
So it is an awesome example of combining artificial intelligence and crowdsourcing, because a lot of smartness is in the content that is out there, and then you marry it up with the powers of deep learning. So it is really awesome. I'll, Najam, also make here, use this as an opportunity to make a few other quick points. So you mentioned that how giving very few examples, you can get desired behavior out of this model. So that is very lifelike. You know, we don't need, we as kids, we as teenagers, we as adults, we don't need too many examples. We don't need millions of examples to, you know, learn something or behave. So I get it. So here we have trained it on enormous data, but we can then set the context of this model, and then we can do things like what is called zero-shot learning, one-shot learning, few-shot learning. So a zero-shot learning, Phil, would be, okay, just told GPT-3, hey, we are going to talk about, you know, Hannah Arendt. And GPT-3 says, all right, let's talk about Hannah Arendt. And you don't have to do any more prompt engineering, and you can talk about Hannah Arendt, and, you know, her political philosophy or what have you. So that would be zero shot, right? So you do not have to give any other than just mentioning the topic, right? Then one shot would be, you say, okay, I'm also, you know, not only I'm saying we are going to be on this topic, but here is a sample example of, you know, if I say this, then you say that. And then it just, you know, you don't have to do any more priming or guiding or prompting. That does the trick. And then few shot is just where, as opposed to doing 0 or 1, you just do few, you know, handful, you know, 5 or less examples. But that is extremely workflow efficient, meaning if you are working with a model like GPT-3 and you know that you have to talk about all these things, and GPT-3 is the model that is going to generate all the right behaviors and outputs, then even for an application that is extremely multi-user, very fast, highly parallel, highly decentralized, you can use the GPT-3 API to quickly set and reset these contexts and these contexts to evolve. And even though in its current form, you know, its memory is 2048 tokens or something like that, you can do a lot of clever engineering around it and do all kind of great things with that. I get excited, Najam.
Mm-hmm.
It sounds quite powerful in practice today. Najam, do you see any limitations today with GPT-3?
Oh, absolutely. Yeah, as a matter of fact, I just thought of another one. Let me show you what I have so far. So for one, like the fact that it is indistinguishable from human generated text is of concern, right? So in the same way that now we're seeing AI produce video deep fakes of people that are really hard to tell. They're almost impossible to tell whether they're actual video or not. The same applies as a matter of fact, that applies even more strongly to text, right? So if you can't tell whether or not a press release is genuine or not, right, that could cost a business in real dollars if action is taken on something that's false, right? You could potentially ask GPT-3 to produce thousands and thousands of fake articles or misleading information and just flood the internet, flood the social media with items that are both false as well as varied enough to seem as though they're written by, several thousand people, right? So that sort of thing in itself is pretty concerning, right? And then there's the fact that it is ethically blind, right? It doesn't know the difference between right and wrong. It just produces the sort of text that you ask it to produce, right? And so since it's being trained on the internet, that means that all of the, negativity, toxicity, profanity that you find on the internet could potentially find its way into the output that it generates. And then something that's related to that is that if there are biases, either, I don't know, against particular people or against particular ideas or particular institutions, then all of that can find its way into the results that a model like this can generate, right? So that's exactly why OpenAI has kept GPT-3 specifically as closed beta instead of releasing it to the public. It's an API that you have to sign up on a waiting list to participate in. And they have mechanisms in place where you can actually report issues like this, where the model is generating things that are either just false or something like that, or that are concerning for ethical reasons. So super important. And the other thing that I wanted to bring up is the authenticity of the output that it produces. In other words, we can say that it can lie, right? So it can produce information that actually is not factual, right? If you set certain parameters to produce very creative responses, then it doesn't really stick to the facts, right? It can come up with really fanciful statements that, while are grammatically correct and they make sense, and they may actually be very well written in terms of someone's writing ability, but they may be absolutely false. And GPT-3 doesn't care, right? Because it's just a machine that's taking in text and churning out text. So all of those things are things that need to be kept in mind when you use a tool like this. There are ways to mitigate that. You can set certain parameters so that the output that the model produces are very deterministic and follow the examples that you provide more closely. And those are some things that you can do to prevent that. But it is still a concern, right? Because if you treat GPT-3 to be some sort of oracle that will provide any response or the response to any question that you ask it, because you know that it's been trained on all of the internet, that really won't happen, because a lot of what's on the internet is just made up, right? So those are just some of the issues.
Yeah. Interestingly, Najam, it raises several interesting points for the future development of these models. The first, it is very clear that we are in the very early stages of this technology in some loving, positive way, the Wild West sort of analogy of working with these models. But made some really good points that made me think and say the following. On the authenticity versus fake front, I see convergence of some technologies down the road. I see blockchain converging with AI and people using more and more, people and businesses and teams, NPTs, or these non-fungible private tokens, as a way to attach authenticity to any content, whether text or image or sound, any digital manifestation of a content. We already have started seeing some examples of artists attaching NPT tokens, these NPTs, to their content. So I see that coming. Second point I'll just quickly make is, based upon what you have said thus far, this whole notion on, so you want to learn, you want to teach your kid, everything that you want her or him to learn. So what do? Do you send them on a 100-year journey to meet anybody and everybody out there in the jungle, wherever, or do you send them to a school or an academy? Or point is, we are very careful in our own development. What is that training data set? What books do we read? What classes do we take? Which schools do we go to? Who do we listen? Who do we not? To your point, Najam, internet is a wall. Anyone can write on that wall, and people do. And a lot of it is just rubbish. And now a good majority of the content that is being written on internet is not even written by people, it is written by bots. So this point on training these models on the right kind of data and addressing those bias points, variance points, and some of these ethics points, and then what kind of behaviors we want from these models. I think those are very sort of important questions, and there are, I think, architectures that will emerge. So what I mean by that is, so you'll have models like GPT-3, maybe they are horizontal and they are trained on everything that is out there. But then there are models on top of it. And they prime them and prompt them and guide them and get the desired behavior out of it. And there is this reflexive loop where, as opposed to just taking an answer from GPT-3 and feeding it in whichever workflow that you have, you say, well, no, wait a minute, not too quick. Let me make sure that it passes my plausibility, feasibility, whatever other criteria that I have for a given domain that I have. So I see, again, a lot of such architectural play. What do you think, Najam, about that?
Yeah, definitely. There has to be some sort of vetting mechanism to make sure that we're not running into the problem of garbage in, garbage out, right? Because data is king, right? Data is key for anything related to machine learning or deep learning. If you provide the most sophisticated model ever with inaccurate or otherwise problematic input, then you're not going to produce the results that you expected. Oh, and the remark that you had about children reminded me that I recently found out that my son, who's now 3, is now a one-shot learner. He may not have been before, but now as soon as he hears a new word, he's like, oh, what's that? And then that's the last time that I'll hear that question, but I'll hear that word repeated far more often after that point. So it is true that we seem to be resembling our technology more and more in this domain. But yes, the point about blockchain is very interesting. That having that sort of hyperledger or some sort of trust-free mechanism in place could be one solution. Now, my team currently is working on some more primitive ways of addressing this. Of course, we could have a list of vetted sources for publicly available knowledge to draw from, and we're coming up with ways to feed information. Even though one important thing to note is that GPT-3 is not a model that we can train ourselves, it's pre-trained. But when it comes to providing the right example, we could point it to whichever web page or whichever sample text we wanted to, and say, okay, well, get the answer from here, right? So that is something we're working on, and we're trying to directly address the issue of authenticity. Is there a way to classify things or score things as more true or less true, or more accurate or less accurate? So yeah, we're trying to make sure that when we sort of add this to a production-ready product, that it isn't, spewing falsehoods or misleading customers or things of that nature. That's crucial.
Yep, absolutely. We've talked a lot about all of the capabilities of GPT-3 and how powerful those capabilities are. How does that capabilities compare to our own capabilities as humans and the human brain?
Right. Well, when it comes to stuff like that, of course, even just counting the number of parameters that have been put into GPT-3, we're not training it on the same amount of data that we train our children even at this point, let alone adults. So if we compare the number of parameters and in a model like this to the number of neurons that we have, or more accurately, the number of synapses that we have in our brains, then there are still several orders of magnitude to go. We probably will get there sooner than we thought we would, which may sound surprising, and especially considering the track record of what we call good old-fashioned AI from before machine learning and deep learning, where everything seemed to be 10 years away all the time. Now we're actually being pleasantly surprised, and in some cases outright shocked at the rate of progress that we've been able to achieve recently. Now, in terms of the style of learning that happens in our brains versus the style of learning that we see in machine learning in general, or deep learning, or GPT-3 in particular, it's clearly not the same, right? So we can't say that these are modeled after our biological neurons, atom for atom, or anything like that. They're loosely modeled on the way that neurons are connected to each other, and the sort of action potentials and things like that that we see in the brain. But it's definitely a very rough abstraction. However,
very rough, very rough, very loose in that sense. One thing, Najam, that I want to say before you go into showing some of your playing with GPT-3 and how we are using it is, I am a fan of this mind map that you are showing on the screen right now. I love how you have drawn it from left to right. I am in general a big fan of mind maps for the following things. They bring topological sort of, visualization to the forefront. So before we write, a lot of text or a lot of this output or that output, and from concepts that are pre-language, more in a thought stage, I think both for human consciousness and machine intelligence and then machine consciousness, mind maps and topologies are an extremely underused tool. The thing about topology is that you can figure out in any space, It could be a space as abstract as ideas and concept space with few keywords and stuff, how different concepts and ideas are connected to each other. Which node is connected to which other node? I always kind of use this, tube station, subway station sort of, analogy. I always think about the London tube network. And so topologies are very powerful. They are also computationally much less expensive to compute. And we will, in some maybe future conversation, talk about topology as a step before we get into geometry and distances, which are extremely compute intensive. And today, deep learning certainly for its training and learning and is using geometric methods. I also want to say one other thing. We were just talking about human brain, sort of as an analogy. So the deep learning of today, in my humble opinion, it does not resemble what goes on in a human brain. As Najam said, it is just a loose analogy at best, kind of a thing. I mean, our brain runs on 12 watts, 12 watts. To try to create something comparable in today's computer architectures, deep learning as part of it, you're talking about, gigantic energy and heat creation and giving the negative gift of entropy to the universe and whatnot. So certainly a lot more to come. But I just wanted to make this point on, I love mind maps, especially the way you have done this one. And they are very visual. You can even have an understanding of time. You can even have a concept of recursion. And I think that as AI have to start sort of, inspecting or, going to reflexiveness and whatnot, mind maps can be good communication tools. Like, we talk a lot about interpretability and explainability. Mind maps can come handy. Mind maps can come handy in an AI trying to explain to another AI what it is talking about, or any AI human combination. So anyways, we'll, hopefully dedicate some future episodes on mind maps and topologies and geometries, but let's first see some GPT-3 in action.
Absolutely. Yep. So let me just bring up a demo instance that I have here of the algo software that we have GPT-3 embedded in. We're just using this for development and playing around with the conversational capabilities. And let's ask it a question. Let's ask it something fun. Let's say, how long ago did velociraptors live? Right, so no training on velociraptors took place before this podcast, so this is just whatever it has learned before 2019. So, okay, cool. I'm guessing that's accurate. And let's see, what did they eat, right? Oh, they ate meat. And so I didn't have to say, I didn't have to say velociraptors this time, and I just understood. Just to make sure that we're talking about the same things, let's say, could they fly? They could not fly. Okay, so we're clearly talking about the same things. What city is their basketball team from? I wonder if it'll catch on. Nope, wrong. Well, Toronto is the right answer there. But in any case, it is producing some interesting responses. And just one other example, let's say something a little more practical. Where are the largest reserves of iron ore? Okay, cool. So, you know, it knows quite a bit. If it's on the internet, then chances are the GPT-3 will be able to answer this, except for things that happened in the past couple of years. So, you know, it seems to be intelligent. It seems to maintain context. If I ask it, what were we just talking about? Let's see what it says. The largest reserves of iron ore. Very good. What were we talking about before? There you go. So, you know, it has short-term memory. It is limited, but it is doing quite a few cool things.
I think this is amazing because even with this, first of all, my prediction, GPT-3 this year will be replaced by something else, GPT-4 or whatever. And Najam, to your point, the acceleration cycle has picked up because of exponential progress. It is no longer 10 years. Now things are happening. A lot happens within a year, or in a 12 to 18 month period, a lot happens. But even in its current form with GPT-3, you're just adding a parser, a reflexive loop that first knows how to use it in the right context, and then to have some kind of quick plausibility scoring or feasibility scoring. I think a lot of very powerful applications can be engineered using the GPT-3 API. So I'm like, you know, somebody who reads a lot about neuroscience and just how context and short-term memory and attention works in our own brains. And even though this is totally different architecturally, it's amazing in terms of the type of things that we can do with that. So exciting.
Yeah, absolutely.
If I'm thinking about when I speak with someone in customer service and through, you know, a chat box, like if I'm returning an Amazon package that I purchased and, you know, I wanted to talk with customer service, this is how I feel companies like that could use this type of technology.
Right. Velociraptors, that's like, oh, Velociraptors are cool. Yeah, they are, yeah.
So
they're very cool. This is awesome. I just get excited about, you know, the potential applications, all of this. And I'll just, you know, quickly say that, look, natural language plays a huge role in how machines and humans we are going to interact, right? So that is the common ground. I have a hope that text based communication, maybe some mind maps down the road, they are going to become a basis of this common language or canonical representations of how we talk, how we communicate, you know, all that good stuff. You should, you know, maybe Najam ask GPT-3 about what it thinks about Chomsky. I was listening to Chomsky's podcast with Kurt Jumangle yesterday, an AMA session. Kurt just does a great job talking to Chomsky, and Chomsky was not all that impressed with GPT-3 for all the right reasons. I mean, he's the Einstein of linguistics, father of modern linguistics. But what an exciting time to live in, and even Chomsky yesterday was very sort of, you know, optimistic about the future of these technologies and what they can bring together, and, you know, their potential, and, you know, all that all that good stuff.
Mm-hmm. So GPT-3 gives Chomsky's theory a seal of approval, so that's great.
Right.
Amjad, you had your you shared with us your prediction for GPT-4. What do you feel like that will look like in the future?
Again, it's not difficult to predict at all. So it's going to be bigger models. So okay, a billion, already 170 billion parameters. So now it would be okay, a trillion parameters, or couple trillion parameters. And then I think more, as opposed to just 2048 tokens for its short-term memory, much larger short-term memories, and suddenly then those APIs will be priced differently and scaled differently if they have bigger or larger or shorter memories, and then ability to prime them and guide them and whatnot. So I think certainly, the people who are designing these genetic models, they have to make money. And so they will come up with all kind of clever pricing schemes. No jab at OpenAI, but it is funny that they have to cover their costs too, and nothing is free. So the paid the proper version of API you have to pay for. And then I'm sure they are thinking about, oh, well, we are a nonprofit, but let's set up a for-profit, and the for-profit will take this technology to the universe and whatnot. Totally cool. We are operating in efficient capital markets. You have to realize, and capture the value that you are creating. Totally on board with that. But I think it's going to be bigger models, more recent data, not this, okay, we trained batch mode some time ago for data up till October 2019. And that is just an indication of today's current state of affairs. It's not real time, it's batch mode. You're working with a trained model, your using of it is not making it become smarter immediately. Hope that people, are capturing that telemetric data or whatnot. But those are the types of things from a future perspective that I see: more shorter memory, ability to use these models more cleverly, bigger models, models that are not batch mode, more online, and more organic growth, as opposed to saying GPT-3 and now GPT-4 or whatever. Just something that keeps getting better every day or every week. And then you don't have to do this, release, it's just like life. Okay, catching up, caught up on everything that went on yesterday, from CNN to Al Jazeera to Joe Rogan to Lex Fridman to whosoever. So, and everything else in between, right? So that, I think, Phil, is what I hope to see over the next 12 to 18 months. And then from a business point, Phil, I'll make this point. People who are coming up with these horizontal models or vertical models, these are new businesses. These are new business models. There are hundreds of billions, trillions to be made in new economy over the next few decades with this. So companies who come up with these models offered as clever APIs to the universe, and they let them, people do their own branching. Okay, you gave me this brain, I'm now using, since we earlier used a very loose connection between AI and human brain. So now I'm going to, in this branching, I'm going to use the many words interpretation, the Everett interpretation of quantum mechanics of many words. So say, okay, let me create my branch. So you gave me, a model, and I started training it with my own stuff. So I now have my own little branch, my universe going on. Okay, I will pay for whatever the right fees are. And then I have the generic model available as well. And create an ecosystem. OpenAI, if you're listening, create, or whosoever who's listening, create an ecosystem. Let people build upon it. Meaning, you have a model, let people create their own branches. Let those branches come to a marketplace. Let everybody in your ecosystem make a lot of money.
So that means
That, my friend,
we'll see people basically create a Git fork of a model and then just run with it.
Mm-hmm. Same thing.
Same concept. One thing that I'd like to add is that I'm really interested to see what sort of behavior will emerge from the next iteration of GPT-3. Right now, we have all of this personality and style and tone that we weren't expecting, and a lot of use cases that didn't seem to like logically follow from a GPT-2. But it's hard to guess at this point what emergent phenomena we'll see in the next version.
Yeah, difficult to predict. But you are so right, Najam, that the generic models have to make an attempt at making them as neutral, as vanilla as possible, so that then applications can add all that color and context and whatnot. And you're right, again, using your analogy of consciousness loosely here, if internet is a conscious being and GPT-3 took a snapshot of it on some date in October of 2019 or whatever, and it is a reflection of what is that personality? It looks like it is a, sometimes angry, sometimes naughty, sometimes serious, sometimes whatever. It has a very complex personality, and probably all kind of personality disorders as well that we can find in a psychiatry book. So the thing is, where sometimes less is more, meaning the same way that you wouldn't, let your kid just learn everything that is on internet, and you are conditioning, you are constraining that training with what type of input goes into that brain. So I think those type of thoughts have to come into the models. And again, they can be multi-layer, that a base layer, okay, trained on everything. Then a layer on top of it, depending upon what it wants to do, does some conditioning. But I hope that the base level models themselves take personality out, make them as bias-free and as vanilla as possible. And also, Najam, start differentiating between facts and opinions. Like, for example, for us to be able to prime it and say, not interested in opinions. We are on, I'm looking for factual answers. Okay, I want opinions, but on this case, I need opinions from X, Y, and Z experts. And to be able to say, okay, X, Y, and Z experts, and then you can go and give maybe 20% weighting to everybody else. So 80% weight to these experts, and the other 20%, because then you are choosing, right? I'll just use this other very quick example of this exact phenomenon of learning from internet. So I have a lifelong passion of studying quantum mechanics. As Feynman said, it's, nobody really understands quantum mechanics. And he said it, in early 80s or maybe late 70s. And in 2021 still is so true. However, a lot of progress has been made as well. But internet is flooded with wrong stuff. However, it is important to note the wrong stuff is being promoted by YouTubers who have 100,000, 200,000, 1 million, 5 million subscribers. So their content gets all this attention, but it is wrong. They are so doing such a bad job teaching people quantum mechanics, because I can see tens of millions, hundreds of millions views on these quantum mechanics posts. So I needed to learn some specific topic, or I needed to do a refresher this past weekend. So I said, okay, what is the trusted source? So I think Professor John Preskill at Caltech, in my opinion, my context, I consider him to be the trusted source on quantum mechanics. So I found him on YouTube or on some Caltech thing in a channel that had, few hundred subscribers, and there are few dozen views to a given lecture. But that is the lecture that I was looking for. I listened to it 3 times. Extremely high quality content compared to there are hundreds of millions of views on quantum mechanics spread by YouTubers and internet who have no idea what they are talking about. And so that is the danger, Phil, of the wrong. So let's say now you train GPT-3 on quantum mechanics, just quantum mechanics. Well, and it is a powerful GPT-3. It is learning from the text and from the videos and from everything that is out there, right? Okay, unless you are careful, it is going to learn from all those people who have that fan following of millions of subscribers and hundreds of millions of views and so many sort of positive points, because what they are saying it in such a loving, sugar-coated fashion of spreading all this wrong information unknowingly. I'm not saying that they have malicious intentions. They're just people out there who have an opinion about it. I don't think the GPT-3 will pay any attention on itself to John Preskill. Because you say, who is John Preskill? Okay, nobody is listening to this guy or whatever. Unless you say, I'm going to constrain the input. I'm only going to let quality input to my model. So that is then, so then as you get specific into specific topics, I as a person, went to YouTube, I looked at few things, read them, because my first thing was, okay, if something has 100 million views, must be good, 100 million views. And then I listened to it because I had that expert knowledge of quantum mechanics again as a student. I said, this is bullshit. And it is bullshit in the sense that so many people are listening to it. Then I said, okay, my God. And then I kind of, asked myself the question, okay, if I were to listen to one person who is alive today on quantum mechanics, who would that be? I said, undoubtedly, John Preskill at Caltech. Then I found it. It was not that easy. He had a fan following of few hundred people. I mean, he's very important in his own circle. So I'm not trying to belittle John Preskill. I'm a big fan. I'm a big fan of John. But that is how I added more to my knowledge on a specific topic on quantum mechanics this past weekend. The normal choice was just listen to a YouTube video that has few hundred million views on it and consider that as the version of truth. That is, Phil, the danger and the challenge that is sort of, all this noise that exists. So on internet, very little signal, a lot of noise. And that also is a job of the people who are designing these tools to see how to differentiate signal from noise. And then somebody can say, but hey, then you are bringing your opinions and biases and whatnot, that is a form of bias too. So it's not an easy topic, but I'm not offering any solutions about my pay grade. I'm just shining light on this problem that we talked about. So anyways, I know
So
that we're
Amjad,
running out of time.
that's actually an interesting question. Could perhaps GPT-4 or 5 or 6 come up with a sense of judgment? Can that sort of emerge by studying all of this information, all the input that it's receiving? Could it perhaps tap into things that seem to be uniquely human, like conversational implicature, right? So the example that my professor, John Vervaeke, used to give us was, imagine there's a person, he's in a car, he pulls up to someone standing on the sidewalk, he pops his head out and says, "I'm out of gas." And then the person in response says, "There's a gas station 2 miles away," right? There's nothing in the question that logically is connected to that answer, right? It's all this implicature, right? So maybe that's something that GPT-4 or 5 could pick up, maybe a sense of judgment to how can one determine quality versus popularity, right? Maybe
Quality
those
over
sorts of things.
quantity, quality
Mm-hmm.
over popularity. So those, I think, Phil, we would all hope to see from future versions of these models. GPT-3 is a huge milestone, no two ways about it. But it is a short-lived milestone. You know, it gave equal weighting to both the signal and the noise. And I think what we are saying here is a way for future models to differentiate signal from noise and giving the users of the model a way to say what is signal and what is noise. Because signal noise can be, two very relative things. Maybe I am a new age spiritualist, and I want this spiritual quantum mechanics descriptions that internet is flooded with, and maybe I don't like John Preskill as a spiritualist, new age guru. I want all that other quantum consciousness stuff. So I will listen to that. I will listen to Sean Carroll and John Preskill, but maybe I'm a serious quantum mechanics student. I will then listen to John Preskill and Sean Carroll versus listening to the quantum spiritualists, that internet is flooded with. So having an ability to, train these models, and these are just generalist examples. If you're using, this issue is much broader, but hey, those are the expectations from these future models. But even in their current or near future form, there's a lot of engineering you can do and fill that into useful applications for your business today. Again, this is not we don't mention any, commercial stuff here, but what we do every given day, we are leveraging it to our benefit. So others can too. So that is the excitement.
Absolutely. Well, hopefully more people will listen to John Preskill after listening to our podcast today. I'll get some more views. That's the goal. I certainly learned a lot today in our chat, so appreciate your insights, Najam and Amjad. Great mind map, and certainly look forward to our continued discussions and to be continued.
To be continued.
Thank you all.
All right.
Thank you.